So in the last class, we were discussing about the concept of oceanic salinity, and we also covered the major and minor oceanic bottom relief. What are the major oceanic bottom relief? Yes, continental shelves, so rise and deep sea plains, abyssal plain. And what are the minor relief feature? Trenches, atoll. Yes, yeah, yeah. So where do we find canyons and trenches? Where do we find canyons and trenches? No, at which regions you are finding the trenches and canyons? In the continental slope region. Okay, so because they are being found at the continental slope region. And where do you see the formation of reefs? Where do you see formation of reefs? Where do you see? Good morning. Good morning. Where do you see formation of reefs? In the continental shelf region. Yes, okay. In the continental shelf region where water is shallow in nature and there is a clear transparent water, there you see the concept of reef region. So what are the different type of reef we have discussed? Fringing, barrier and atoll reef. Okay, those are the three different type of reefs we have discussed: fringing reef, barrier reef and atoll reef. And then we started with concept of oceanic salinity. We discussed what is salinity. It is amount of salt. Yeah, amount of salt in gram dissolved in 1 kilogram of seawater. So that is what we call as oceanic salinity. And we discuss what are the factors that are determining your oceanic salinity. So we discuss evaporation. Second we discuss is what? Precipitation or rainfall. Third is addition of fresh water by rivers, by melting of ice and etc. Then we discussed tide water glaciers, and we also discussed another one, which is oceanic current. So those are factors which are influencing your oceanic salinity. Fine. So which type of salts are generally found inside the ocean? So you have sodium chloride, that is NaCl, calcium sulfate, magnesium chloride. Okay, these are these are the salts that you find. Calcium chloride also. These are the salts that you generally found inside the oceans. But highest concentration of salt that you'll find is of NaCl. Okay, that is the sodium chloride. 77% of the salt that is found in the ocean is your sodium chloride. But other salts are something that are also present. Why sodium chloride is present in more amount? It is present in more amount due to residence period. Why it is present in more amount is due to residence period. What is residence period? It is the time for which the salt can remain dissolved in water. Can remain dissolved in water. Fine. So time for which salt can remain dissolved in water is referred as what? Is referred as a residence period. Since NaCl can remain in water for a long period of time, that's why highest concentration of salt that you find in the ocean is NaCl. 77% of salt, okay, that you find is NaCl only. Fine. Any doubt regarding this particular thing? So what you are finding is NaCl. NaCl is what? NaCl is maximum present in the ocean. Why it is maximum present? Because it has a higher residence period. It can remain dissolved in water for a long period of time. Fine. Now, the important thing that you have to keep in mind is, where do you see more salt concentration? Where do you see less salt concentration? Where do you see more salt concentration? Where do you see less salt concentration? So variation of oceanic salinity. So next point is variation of oceanic salinity. There are two things you have to keep in mind. One is horizontal variation of salinity, and second is vertical variation of salinity. So variation of oceanic salinity, what you have to keep in mind is two things. One is horizontal variation of salinity and second is vertical variation of salinity. Fine. So what is horizontal variation of salinity? What is horizontal variation of salinity that you're going to find? Let's say this is a water. This is a water. When you are measuring the salinity from this point to this point, this is called as what? This is called as a horizontal variation of salinity. How salinity varies at the surface of the water, clear, is called as a horizontal variation of salinity. So how salinity varies at the surface water is referred as horizontal variation of salinity. And what is vertical variation of salinity? This is vertical variation of salinity. This is vertical variation of salinity. So how salinity varies from surface to depth? How salinity varies from surface to depth is referred as what? Is referred as a vertical variation of salinity. So there are two types of variation. One is horizontal variation of salinity, another is called as a vertical variation. Horizontal variation means we are worried about surface, okay, surface variation, how salinity varies at the surface, and vertical variation means we are okay seeing from the surface to the depth. How salinity varies from the surface to the depth is called as a vertical variation. Fine. So let's say this is okay, what? This is the water. Assume this is okay, the water that is okay there. Now we are considering this water from where to where? We are considering this water from the equator region to which region? Polar region. We are considering this water from where to where? From equator region to the polar region. So let's say this is equator region. This is okay, what? The Tropic of Cancer or Tropic of Capricorn region. Tropic of Capricorn region. And this part, okay, is okay where you'll find polar region. So here is polar, here is Tropic of Cancer, Tropic of Capricorn, here is the equatorial region. So now we are considering how the variation of salinity happens in this particular surface region. Clear? So first we are taking up which type of variation? Horizontal variation. Horizontal variation of salinity. Horizontal variation of salinity. Fine. So first we are taking up which type of variation? Horizontal variation of salinity. Clear? Now at equator, what you are finding? At equator, you'll find more rainfall. At equator, what happens? More rainfall. Why this rainfall happens? Because equator region is heated more. So air is also heated. As a result, expansion, and you will see more rainfall. So at equator, you will see what? You will see more rainfall. More rainfall means what? More rainfall means what? More addition of fresh water. More addition of fresh water. So at equatorial region, you will see precipitation is greater than the evaporation. At equatorial region, you'll see precipitation, rainfall is greater than the evaporation. More rainfall happens. More rainfall means what? More addition of fresh water. So what will happen to the salinity here? Yeah, salinity will decrease. Okay, so lower salinity are being observed in a equatorial region. Lower salinity are being observed in a equatorial region. Fine. Now, as we are moving from here to here, from equator to the Tropic of Cancer or Tropic of Capricorn, what will happen to salinity? Now the salinity will increase. Salinity will increase as we are moving from here to here. Why salinity is being increasing? Because tropics are the region of what? Tropics are the zone of, they are the zone of high pressure. Last class we discussed tropics are the region of high pressure. High pressure means what? Less rainfall, more evaporation. So at the Tropics region, you're going to see less rainfall and more evaporation. So evaporation greater than the precipitation. As a result, what will happen to salinity? Salinity will increase. As a result, salinity will increase. So when you are moving from equator towards nothing but Tropic of Cancer or Tropic of Capricorn, you'll see increase in case of salinity. That is okay there. Clear? Now, as you are moving from here to here, that is increase in salinity till nothing but polar region. When you are moving from here to here, you'll see again a decline in salinity. We'll see again a decline in salinity. Salinity will decrease. Why salinity will decrease? Yeah, glacier melting will add fresh water over here. So you'll see addition of fresh water through glaciers melting. And also here what will happen? Evaporation will be lesser. Why evaporation will be lesser? Yeah, no sunlight. Okay, no sunlight in the polar region or less sunlight in the polar region. So what you see is here precipitation is also low, evaporation is also low, but still salinity is low because of addition of fresh water through glaciers. So precipitation is also low, rainfall is also low, evaporation is also low, but addition of fresh water is being done through melting of glacier. So that's why salinity is going to decline. Clear? So this is how you see variation of salinity from where to where, from nothing but equator to polar region. So salinity increases when we move from where to where, from equator to Tropic of Cancer and Capricorn. Thereafter you'll see decline in case of salinity, and again lower salinity is being observed in the polar region. So this variation is called as a horizontal variation of salinity. Clear? Next we are coming to the vertical variation. What is vertical variation of salinity? Yeah, from surface to the depth. Fine. So what you're going to find is what you're going to find is how the salinity is going to vary. So salinity at surface is generally lesser. Salinity at surface is generally lesser. As we go deeper, salinity becomes what? Salinity becomes more. So at the surface, you generally see salinity are lower. As we go down, salinity generally increases. Why do you see increase of salinity when we go down? Why do you see increase in salinity when we go down? Yeah. Yeah. Yeah, correct. Okay, so as we discussed, salt water is more denser. So as we discussed, salt water is what? Salt water is denser. So salt water will always move down, while while the less salt water is what? Less salt water will come up because it is less denser. So always there is a movement of water, less dense water will move up and more dense water will nothing but move down. And also at the surface, what is happening? At the surface, you see addition of fresh water can be done. So when rivers comes and meet, or when ice melts, or when rainfall happens, all these will add water where? All these will add water at the surface. Okay, all these will add water at the surface. That's why at the surface, salinity keeps on varying. Salinity keeps on changing. But at the bottom, you see generally salinity are fixed. Salinity are fixed. They are not much changing. Because there is no evaporation taking place, no addition of fresh water is happening, no addition of fresh water. So that's why you see salinity is generally fixed at what? Salinity is generally fixed at the lower position. It is not changing at the lower position. Well, the salinity keeps on changing at the surface position. And since the saline water is more denser, saline water always comes down. Less saline water always go up. So this is how you see vertical variation of salinity. This is how you'll find vertical variation of salinity. Fine. So remember, okay, how horizontal variation of salinity will occur and how vertical variation of salinity will occur. Fine. So that's why the salinity of the oceans, as we discussed, 3 oceans are there: Atlantic Ocean, Pacific Ocean, and Indian Ocean. You'll find these oceans, salinity keeps on varying at different places. At different places, you'll find different salinity. You'll find different salinity. Fine. So you have to explain salinity of different oceans. So how you'll explain that salinity of different ocean? Generally at the equatorial region, at the Atlantic or at the Pacific, you'll see what? Lesser salinity. As you go up, move towards what? Tropics region. In the Atlantic Ocean and in the Pacific Ocean, what will happen to salinity? Increase will happen, and then again decrease will nothing but okay happen. So this is how you are going to explain the variation of salinity across the oceans. Fine. Any doubt regarding this particular part? Now, what you keep in mind, there is a term called there's a term called pycnocline or pycnocline, Pycnocline, pycnocline. What this term pycnocline means? Now, you'll observe a sudden change when you are moving from here to here. Like when we are moving from there to where, when we are moving from here to here, you'll find a sudden increase in density. At this layer, you see quick changes in density is happening. Here, what will happen? We discussed which type of water is there. Less dense water. Less dense water is over here. And at the bottom, which type of the water is there? More dense water. So there is a junction where you see a quick change in what? Quick change in density is happening. This junction is referred as what? This junction is referred as a pycnocline. Okay, this junction is referred as a pycnocline. So pycnocline is basically what? It is a boundary. It is a boundary separating water of 2 different density. Water of 2 different densities. When you are separating water of 2 different densities, then it is going to be called as what? It is going to be called as nothing but okay, pycnocline. Fine. What will happen to salt concentration? Just now we discussed salt concentration is going to be what? Salt concentration is going to be lower at the surface, and as you go down, what will happen? Salt concentration is going to increase because saline water is more denser, it sinks down, and okay, this water is okay, what? This water is less denser. So you can see again this variation is what? This variation can also be seen for whom? For the salinity also. Like we discussed the variation for density, like that, okay, this variation can also be observed for whom? For the salinity also, because saline water is more denser, so it is going to be down. Less saline water is okay, what? Less denser, so it is going to be up. So when this variation of salinity is being observed, okay, when this variation of this salinity is being observed, it is referred as a halocline. It is referred as a halocline. Halocline means what? It is a boundary separating water of different salt concentration. water of different salt concentration, the term is referred as a halocline. Okay, the term is referred as a halocline. Clear? So pycnocline, if the question comes regarding pycnocline is going to be what? The change in density boundary, that is okay, signifying a change in density. While okay, the similar thing that you find with regard to halocline is representing what? Halocline is representing the change in salt concentration. Fine. There is also a term, the third term, which is referred as okay, what? Which is referred as a thermocline. Thermocline. Yeah, as the name indicates, thermocline means what? Temperature. Okay, it is showing a variation in temperature, that is going to be referred as what? Thermocline. Clear? So where do we find more okay, what? More temperature of the water? At the surface. Why? Due to sunlight. Anyone else? Anyone else? Okay, as you go down, okay, in the interior of earth, what happens to temperature? Temperature also increases as you go down. Okay, so there is a earth's heat also. So as we discussed, because of the earth's heat, temperature also increases, that is okay there. So whether at the okay surface you are going to find more temperature, or at the bottom you are going to find more temperature? At the bottom. Anyone else? So keep that in mind, both concept. Okay, sun's heat also, earth's heat also. Clear? So what you have to keep in mind is what? What you have to keep in mind is, as we discussed, warmer water is going to be where? Warmer water is generally you're going to find on the surface. As you go down, what will happen? A cold water is going to be there. As you go down, coldness is going to be there. Till what? Till nothing but okay, up to a certain extent, okay, you'll see increase in what? Increase in sorry, till a certain extent you'll see a decrease in what? Decrease in temperature. Clear? So what you see is okay, temperature variation is also like this to a certain extent. Okay, to a certain extent you'll find temperature variation also like this. Fine. So this is referred as what? This is referred as a thermocline. Clear? Any doubt regarding this particular thing? So as the okay volcanic eruption and other eruption happens, you see new lava will come out. Lava will heat what? Lava will heat the water. Remember, when lava will heat the water, what will happen? What will happen? Then the water will become less dense. Less dense water will starts to come up, and more dense water will starts to nothing but okay sinks down. Okay, that is okay there. So this circulation process can start. So when lava comes out, lava can heat the water, then water becomes less dense. When water becomes less dense, it is going to rise up, and the more dense water is going to come down. That is okay there. Clear? So that's why you'll see variation also in case of what? Variation also in case of temperature, and this is referred as what? This is referred as a thermocline. This is referred as what? This is referred as a thermocline. So thermocline, what definition you can write? What definition you can write? Boundary separating water of two different temperature. Simple thing, you can find boundary separating water of two different temperature is going to be referred as what? Is going to be referred as a thermocline. So three cline you have to keep in mind. One is called as what? One is called as a pycnocline, another is called as a thermocline, and the third is called as a halocline. Fine. Fine. So now can you explain last class? Okay, we discussed, question has come that explain what? Variation in salinity at different okay what? Different ocean, and what is okay the impact, okay, why we are studying the oceanic salinity. So last class we discussed, or what are the multi-dimensional impact of salinity. We discussed that question was asked in 2017 paper. So multi-dimensional effect we discussed was what? That it determines evaporation, it determines what? Precipitation, it determines compressibility, expansion, all those particular things are determined by whom? Salinity. And what, how you'll explain that different variation in salinity? So we discussed Atlantic Ocean at the equator, salinity will be generally lower. As you move towards what? As move towards tropic, salinity will increase. Then again, as we move towards polar region, salinity will decrease. Okay, so this is true for all the oceans. Okay, that is okay there. Clear? So this you have to keep in mind with regard to horizontal variation and vertical variation of salinity. Fine. Now there are salinity. Now salinity variation can also be seen in case of marginal seas. marginal sea, and also in case of land. Salinity variation can also be seen in the case of marginal sea also and on the land also. Can you see this one? This is what indicating thermocline, halocline, and pycnocline. Okay, that is okay there. So as we discussed, this is less salinity. This is nothing but okay, more salinity. That is okay there. So as salinity will increase boundary, it is going to be called as what? Halocline. Here, what is pycnocline is indicating what? Indicating the density. Well, this is indicating what? Indicating nothing but okay, temperature. So this is how you are seeing nothing but okay, variation. So here warm temperature, here cold temperature, here less salinity, more salinity, less dense water, more dense water. So this is referred as pycnocline, halocline, and thermocline concept. Fine. So this is the diagram. Just okay, keep in mind whenever question comes regarding explaining the different thing, you can use this particular diagram to explain things. Fine. Fine. Now, next we are moving to the salinity variation in marginal sea region. So what you have to keep in mind is this region is referred as which sea? Red Sea. Okay, so last class we discussed this is a Red Sea region. Okay, this is which region? Persian Gulf. This is which region? Persian Gulf. This is which region? Caspian Sea. This is which region? Black Sea. Fine. This is which region? Mediterranean Sea. This is okay. Which region? North Sea. Fine. So these are okay. What? These are different type of nothing but okay. What? These are different type of marginal sea that you have to keep in mind. Clear? Now, what you have to keep in mind is salinity. As we discussed, Red Sea salinity is what? Salinity of Red Sea is slightly higher. Why it is slightly higher? Why it is slightly higher? Yeah, it passes through Tropic of Capricorn. So we discussed in Tropic of Tropic of Cancer. Salinity is okay. The Red Sea is okay. Close to what? Red Sea is close to Tropic of Cancer. And you know the Tropic of Cancer is which type of belt? High pressure belt. When high pressure belt are going to be there, then rainfall is less. So in this region, what is happening? Rainfall is lesser in nature. In Red Sea, what is happening? Rainfall is lesser in nature. And we discuss what is happening. So in Red Sea, salinity is high. Why salinity is high? Because rainfall is less. And the second thing that you see is okay, what? No addition of whom? No addition of fresh water through river. No addition of fresh water through river. So that's why salinity is what? Salinity is higher in case of Red Sea. Clear? Salinity is higher in case of Red Sea. Fine. Correspondingly, you see Persian Gulf has a little lesser salinity. You can see Persian Gulf also lies closer to what? Closer to nothing but okay, Red Sea region. But Persian Gulf has a little lesser salinity. Why it has little lesser salinity? Here also rainfall is less. But Persian Gulf is joined by the rivers. River water comes and joins. So addition of fresh water happens through rivers. Addition of fresh water happens through the river. That's why Persian Gulf records okay, what? Records a bit lesser salinity than what? Lesser salinity than the Red Sea. Clear? What about Mediterranean Sea? What about Mediterranean Sea? Now Mediterranean Sea also records lesser salinity. It records lesser salinity. Why it records lesser salinity? Because rainfall is also more as compared to Red Sea. Addition of fresh water through rivers are also there. Through rivers. Clear? So Mediterranean Sea records nothing but okay, what? Records nothing but okay, lesser salinity. Why it records lesser salinity? Because addition of fresh water is also there, as well as okay, what? As well as rainfall here is also high. Fine. Clear? Next, okay, what you see is okay, Mediterranean Sea has a more salinity than whom? Mediterranean Sea has a more salinity than the Black Sea. Okay, it has a lesser salinity as compared to Red Sea, but it has a more salinity than what? It has a more salinity than the Black Sea. Why Black Sea? Because evaporation decreases here further because you are moving away from sunlight. So evaporation decreases. Evaporation decreases, and what will happen over here? You'll see lot addition of river water. Lot addition of river water. Clear? Many rivers comes and joins the Black Sea. Lot addition of river water. So evaporation also reduces here because sunlight is less over here and more fresh water is being added. As a result, Black Sea records which type of salinity? Lower salinity. Fine. Now, North Sea. North Sea records higher salinity. North Sea record higher salinity. Why it records higher salinity? It records higher salinity. Why? Because we discussed which at the Tropic of okay, what? Tropic of Cancer, what will happen? Higher salinity. Here higher salinity. This higher saline water is taken towards where? Towards nothing but okay, North Sea. Okay, so North Sea record higher salinity because saline water is being brought by whom? Saline water is being brought by oceanic current. Is being brought by oceanic current. So that's why, okay, the North Sea records higher salinity. Okay, North Sea record higher salinity because saline water is being brought by whom? Being brought by nothing but, okay, oceanic current. Fine. Fine. In the same latitude, you will find which sea? Here you will find Baltic Sea. Which sea is over here? Baltic Sea. Baltic Sea records lesser salinity. It records lesser salinity. Why? Because we discussed fresh water is being added through rivers. No oceanic current bringing saline water. No oceanic current bringing saline water. That's why Baltic Sea records something but, okay, lower salinity. Fine. So these things you have to keep in mind. Question might come that why at the same latitude, they are at the same latitude only. Why one records higher salinity? Why one records lower salinity? So one record higher salinity because of saline water being brought. One record lower salinity. Why? Because no saline water being brought over here. Fine. Any doubt regarding this particular thing? So that's how you see variation of whom? Variation of nothing but, okay, salinity. Clear? So you'll see, okay, the higher salinity at Red Sea, you'll see lower salinity at where? At nothing but, okay, Black Sea and etc. That is okay there. Clear? Any doubt regarding this particular thing? So marginal sea have a huge variation in salinity. Clear? Normally we discussed, last class we discussed open oceans has how much salinity? Yeah, 33 to 37 we discussed. This is how the open oceans has, but marginal sea may record what? Marginal sea may record even 70, even 150. They can record higher salinity, okay, because of nothing but, okay, what? Because of this one. So marginal sea can record higher salinity. That is okay there. Clear? So just remember that marginal sea can have more salinity or can have less salinity than the open ocean. Marginal sea can have less or more salinity than open ocean. Remember that. Clear? What about Caspian Sea? What about this sea? So Caspian Sea also record less salinity. It also record less salinity because of addition of fresh water by rivers. Addition of fresh water by rivers, so record lesser salinity. Clear? So Caspian Sea also record lesser salinity because of addition of fresh water by whom? Fresh water by rivers. Fine. Done. So this is how the variation of salinity occurs across the marginal sea. So if you are getting this type of statement in the examination, which is correct? Second is correct. North Sea record higher salinity. So we discussed this is North Sea record higher salinity than the Baltic Sea. Why it records higher salinity? Not because of high evaporation, because both are in same latitude, same type of evaporation happens, but it is recording higher salinity due to what? Due to the salt water being brought by whom? Brought by the oceanic current. So that's why first statement is wrong. Second, Black Sea record higher salinity than the Mediterranean Sea. Yes, Black Sea records Black Sea records lower salinity than the Mediterranean Sea. Yes, this part is correct. Why this is correct? Due to the influx of fresh water. Yes, we discussed many rivers comes and joins the Black Sea. That is okay there. So this second statement is correct. First is wrong. So like this, questions can be asked in the prelims examination regarding variation of salinity. Fine. In doubt. So this is all about, okay, the salinity variation where salinity variation at the oceans. Fine. You'll also find so you can see this region. This is USA. In the USA, you find a lake which is called as what? Which is called as a Great Salt Lake. Okay, so on the land side, higher salinity is being recorded where? Higher salinity is being recorded in the Great Salt Lake. Where this Great Salt Lake is there? This Great Salt Lake is there in the USA. Higher salinity is something that is okay recorded on the Great Salt Lake in case of USA. Clear? So remember that on the ocean side, we have discussed marginal sea generally have a higher salinity or lower salinity, but on the land side, you see lakes are something that are present. Okay, so Great Salt Lake records higher salinity, and the Great Salt Lake is present where? In the USA. Clear? Similarly, you have another important, okay, what? Another important sea. So similarly, you have another important sea. Now, another sea that you find is a Dead Sea. On the land, another sea that you are finding is called as what? Dead Sea. Where do we find Dead Sea? It is being found at the Israel-Jordan border. Okay, so where this Dead Sea is being found? Dead Sea is being found at the Israel-Jordan border. Dead Sea also records very high salinity. It also records very high salinity that you have to keep in mind. Its salinity is somewhere around 220 to 30. Okay, very high salinity is being recorded. And Dead Sea is the lowest point on the land. It is the lowest point on the land. We discussed what is the lowest point on the earth. What is lowest point on the earth? Mining. No. Lowest point on the earth is what? Trenches. Okay. Lowest point on the earth is what? Trenches. Which trenches is most deep? Mariana Trench. Okay. So Mariana Trench is the lowest point on the earth. Okay. Mariana Trench is the lowest point on the earth. Highest point on the earth is Everest. Okay. So highest point on the earth is what? Everest. Lowest point on the earth is what? Mariana Trench. But this trench lies where? We discussed it is a concept of oceanic bottom relief. There we have discussed the trench. So on the land, which is the lowest point? On the land, Dead Sea is nothing but, okay, your lowest point. Okay, so on the land, which is your lowest point, Mariana Trench lies in the oceans. Okay, so on the land, which is the lowest point, Dead Sea is nothing but, okay, your lowest point. Dead Sea records very high salinity. Fine. Why very high salinity? Saline water is there at the deep, and secondly, this lies in which region? This lies in the deserted region. You see Jordan, Syria, you see Saudi Arabia. These are what? These are deserted region. Less rainfall happens in this particular region. So more evaporation, less rainfall. So, okay, which type of salinity is going to be there? Higher salinity is going to be there. Fine. Next important point that you have to keep in mind is a lake van. So another important that you find is a lake van. Lake van is lying in case of Turkey region. So you can see this is a Turkey, and this is where Lake Van is lying. Lake Van recorded the most, okay, what? Most higher salinity. Okay, salinity here is around 330. Okay, so highest salinity is something that is, okay, being recorded over here. Around 330 salinity is something that is, okay, being recorded in a Lake Van. Okay, so Lake Van, Dead Sea, the Great Salt Lake, these are the regions which record higher salinity on the lands. Fine, in doubt regarding this one. So remember, on the oceans we discussed which are the oceans that are recording larger salinity. Yes, Pacific oceans are recording, okay, salinity much higher because of their greater extent. Then we discussed, okay, marginal sea, you are generally seeing what? You are generally seeing the Mediterranean Sea records higher salinity, Red Sea records higher salinity. We'll see the North Sea record higher salinity. So those are the salinity regions that record higher salinity. And on the land, we discussed which are the regions which record higher salinity: Great Salt Lake, Lake Van, and Dead Sea. Clear? Any doubt regarding this one? So this is all about salinity variations. Okay, clear? And one more thing that you have to keep in mind is we have discussed the term thermocline. No, one more thing which I forgot to add. So we have discussed this term thermocline. Just add one more point over here. The region where you see warm temperature. Why this here warm temperature are there? More sunlight. More sunlight. So this region is referred as which type of zone? Photic zone. This region is referred as which type of zone? Photic zone. And this region where, okay, what? Where lesser sunlight is there is referred as what? Aphotic. Where temperature is colder in nature, that is referred as a aphotic in nature. So you have photic and you have nothing but, okay, aphotic. Fine. Any doubt regarding this particular thing? So this is, okay, important thing that you have to keep in mind with regard to what? With regard to your oceanic salinity. Now next we are coming to the concept of what? Concept of marginal sea. Fine. So you can see lot many seas are something that are mentioned in this particular diagram. Okay, as we discussed, Red Sea is mentioned, Dead Sea is mentioned, Mediterranean Sea is mentioned, Adriatic Sea is mentioned. Okay, you're finding lot amount of seas are something that are mentioned in this particular diagram. All these are referred as what? You have Bay of Bengal, you have Arabian Sea, Persian Gulf, Caspian Sea, White Sea, okay, Baltic Sea. These are, okay, sea that are mentioned. Now these sea are referred as what? These sea are referred as a marginal sea. What is marginal sea? What is the definition for marginal sea? So marginal sea basically is a shallow water body region, okay, which is surrounded by which is surrounded by the land. Okay, so it is a shallow water body region surrounded by whom? Surrounded by the land. That is okay there. Clear? So what you are finding here is okay. What you are finding is here is this is okay. We discussed okay. Baltic Sea is there. This is okay where Baltic Sea is there. Baltic Sea surrounded by whom? Land. North Sea is there. North Sea surrounded by whom? Land. Okay. So you'll find Mediterranean Sea surrounded by land. Black Sea surrounded by land. Red Sea surrounded by land. Dead Sea surrounded by land. Caspian Sea surrounded by land. So a shallow body of water that is surrounded by nothing but okay land is referred as what? Is referred as a marginal sea. And marginal sea can be found in the form of what? Either bays or in the form of gulf. They can be found in the form of bays also. They can be found in the form of gulf also. Fine. Like you can see Gulf of Oman is written, Persian Gulf is written, Gulf of St. Lawrence is written, Gulf of Mexico is written. Okay, so they can be found in the form of Gulf or Bay of Bengal. That is okay being written. Then you see Hudson Bay. This is something that is okay being written. So marginal sea can be found in the form of what? In the form of Gulf also. This can be found in the form of bays also. That is okay there. Clear? What is Gulf? Now remember that when a sea is going to be surrounded by whom? When a sea is going to be surrounded by land on the three sides. It is going to be surrounded by the land. On one side land, second side land, third side land, with very narrow opening towards oceans. With very narrow opening towards oceans, such are going to be called as what? Such are going to be called as a gulf. Gulf is surrounded by three side by whom? Three side by the land, with very narrow opening towards where? Towards nothing but okay, ocean. So that's why we call this region as which region? Gulf of Kutch. We call this as a Gulf of Kutch. Why? So Gulf is surrounded by whom? Gulf is surrounded by a land from the three side with very narrow opening towards where? With very narrow opening towards oceans. Then it is going to be called as a Gulf. Fine. Like you can see, this is a Gulf of Mexico. This is surrounded by land, surrounded by land, surrounded by land with very narrow opening towards Atlantic Ocean. That's why it is referred as what? It is referred as nothing but okay, Gulf. Fine. So this important thing that you have to keep in mind with regard to Gulf. The second important thing is what? Second important thing that you find is the bays. Now bays are basically what? Bays are basically, like we discussed, this region we call it as what? Bay of Bengal. So this region we call it as a bay. What is bay? Again, bay will also be surrounded by whom? Surrounded by land on three sides with wide opening towards where? With wide opening towards nothing but okay, oceans. Okay, so bays will also be surrounded on three sides by the land, by but wide opening towards okay, the oceans. Okay, so this is what difference lies between Gulf and a bay. Gulf is what? With narrow opening towards ocean, surrounded on the land by three sides. Bays are what? With the wide opening towards nothing but okay, oceans, which is okay what? Which is nothing but okay, the bays. Clear? Any doubt regarding this particular thing? Now there are few other terms that you also have to keep in mind, which are referred as your strait and isthmus. They are referred as a strait as well as isthmus. Okay, like have you heard about the term Park Strait? What is Park Strait? Have heard anyone have heard the term Park Strait? Where do you find Park Strait? Between India and Sri Lanka. Okay, so Park Strait is where you are seeing Park Strait. So this is okay, India, and this is nothing but okay, Sri Lanka. You'll find okay, a strait over here which is called as a Park Strait. Okay, that is okay there. Clear? So what basically is the term strait meaning? Clear? Now strait is basically a narrow body of water, a narrow body of water connecting two major water bodies. Clear? A narrow channel or a narrow body of water connecting nothing but okay, what? Connecting nothing but okay, two major body of water is going to be called as what? Going to be called as a strait. In the process, strait separates two major land. It separates two major land also. Okay, so it separates two major land also, that you have to keep in mind with regard to term strait. So it is a narrow body of water connecting two major water bodies, and it separates what? It separates two major land part also, that is okay there. Clear? So when we are seeing this region is referred as what? This region is referred as a Park Strait. So what will happen? This is a narrow channel of water connecting Indian Ocean with whom? Bay of Bengal. Two major water bodies are being joined, and in the process separating what? Separating the two land part, which is nothing but okay, India and Sri Lanka. So this is what we call as a term strait. Fine. Like you'll find here something called as what? If you see this particular region, you can see here it is mentioned as Strait of Gibraltar. Strait of Gibraltar. It is separating whom? Africa and Europe, but connecting whom? Mediterranean Sea as well as nothing but okay, Atlantic Ocean. So this is a narrow channel of water connecting nothing but okay, two bigger channel of nothing but okay, water that is okay there. So this is what we called as a strait. Clear? Isthmus is exactly opposite. Isthmus is exactly opposite of okay, the strait. Isthmus is a narrow channel of land. Narrow channel of land connecting two major land, and in the process what will happen? They will separate two water bodies. So narrow channel of land connecting two major land and separating water bodies. Fine. So exactly, strait is a narrow channel of water connecting two major water bodies. Isthmus is a narrow channel of land connecting two major land. Fine. Like example is your what? Example is, if you see this region, so you can see this is a region. Now this here you'll find what? Here you'll find you. I'll just use different map. Now you can see this is called as what? This is called as a Isthmus of Panama. Okay, it is called as a Isthmus of Panama. Isthmus of Panama is a, this region is what? This region is a narrow piece of land. So this region is what? This region is a narrow piece of land. And this is connecting what? This is connecting the Southern American continent with whom? Northern America continent. Okay, so this is connecting which two continent? Southern America and Northern America. This is a narrow piece of land referred as what? Referred as nothing but okay, Isthmus of Panama. Is clear? So what in the process what it is separating? It is separating Caribbean Sea with whom? Pacific Ocean. So it is separating two water bodies also, that is okay there. Clear? So strait is what? A strait is a narrow channel of water connecting what? Two water bodies. In the process they will separate the land. And in the case of okay, Isthmus, what is happening? Narrow channel of land connecting two major land. In the process they will separate whom? The two sea, that is okay there, or two water bodies, they are going to be there. So this is what lies the term Isthmus, Panama, Strait, as well as okay, Bays, Gulf. Okay, so all these terms, okay, just you keep in mind. Clear? So write down regarding important marginal seas of the world. Yeah. Yeah, right. Write down marginal sea. Marginal sea is a water body which is partially enclosed by the land or an island archipelago. Marginal sea is a water body which is partially enclosed by the land or any island archipelago. They are generally shallower than open oceans. Fine. That is a definition you keep in mind with regard to marginal sea. That a marginal sea are what? These are the partially enclosed by land or island archipelago. Like we discussed, what is Gulf? Enclosed by whom? Land with, okay, what? With partially enclosed, not fully enclosed by the land. It is a partially enclosed by the land or any island archipelago, and it is shallower than the open ocean. So this definition you keep in mind with regard to marginal sea. Next heading, you can mention important marginal seas of the world. Important marginal seas of the world. Important marginal seas of the world. And first we write on marginal sea in the Atlantic Oceans. Marginal sea in the Atlantic Oceans. Marginal sea in the Atlantic Oceans. So first we are taking in the Atlantic Ocean. You can mention first sea as Labrador Sea. Okay, so first sea you can mention as which sea? Labrador Sea. Marginal sea and Atlantic Ocean. This is Atlantic Ocean. The first marginal sea that you are finding is which sea? Labrador Sea. Okay, so mention about Labrador Sea. Fine. Second, you can mention about Norwegian Sea. Norwegian Sea. Norwegian, Norwegian Sea.
So that is Europe, right?
Yeah, Europe. This part is Europe. This is Europe. And this is okay. Your Norway. No, here lies your Norway, Sweden, and Finland. These countries are there. Fine. Norwegian Sea. Third, you can mention North Sea. Third, you can mention North Sea. North Sea. Fine. Fourth, mention Irish Sea. Irish Sea. Irish Sea. IRISH. Ireland. Irish Sea. Okay. Next, you mention Bay of Biscay. Next, you mention Bay of Biscay. Bay of Biscay. Fine. So we discussed just now Strait of Gibraltar. We have discussed this strait is separating what? The two Africa and other thing. You can see here it is written as what? Strait of Gibraltar. Fine. So Bay of Biscay is over. Next you mention Gulf of Mexico. Gulf of Mexico. Gulf of Mexico. Next Caribbean Sea. Gulf of Mexico. Next is Caribbean Sea. Caribbean Sea. Another you can mention Bay of Fundy. Bay of Fundy. Bay of Fundy. Fine. Next you mention Gulf of Guinea. Gulf of Guinea. Gulf of Guinea. Fine. Then you can also mention this part, which is called as a Rio de la Plata. Rio de la Plata. Fine. So these are the important marginal sea that you are finding in which region? You are finding in the case of Atlantic Ocean region. Okay, so in prelims, question can be found which of the marginal sea are located in what? Atlantic Ocean. Okay, this type of questions can be formed in the case of examination. So remember that. If you remember the country's location, Norway lies where? Norway lies in Europe. Europe is touching the Atlantic Ocean. You remember Ireland. Ireland lies where? In Europe. So Irish Sea, Norwegian Sea, North Sea. You see Bay of Fundy, Gulf of Mexico, Caribbean Sea, Rio de Plata. So these are okay. The marginal sea that lies in which ocean? Lies in the case of the Atlantic Oceans. Fine. Next heading you read on marginal sea in Marginal sea in Pacific Ocean. Marginal sea in Pacific Oceans. So first you mention about Gulf of Alaska. Gulf of Alaska, ALASK. Alaska was in news recently. Why it was in news? Yeah, Trump and yeah, Putin meeting was there. So Gulf of Alaska. Fine. Next, Gulf of California. Gulf of California. Gulf of California. Fine. Next is next you write on Bering Sea. Next you write on Bering Sea. BERING. Bering Sea. Bering Sea. Fine. So this lies in Pacific. Next is lying the Sea of Okhotsk. Sea of Okhotsk. Sea of Okhotsk. Why this was recently in news? Anyone? Why this was in news recently? Earthquake. Yes. Okay. This is Kamchatka region where earthquake had occurred, which has led to tsunami warning in Japan and Russian region, eastern region. So this is Kamchatka Island, where you see nothing but okay, this has occurred. Okay, so remember that Sea of Okhotsk. Next you write on Japan Sea. Japan Sea. Japan Sea. Fine. Next you can mention Yellow Sea. Yellow Sea. So Yellow Sea is okay, separating what? This part is Korea. This part is Korea region, North Korea, South Korea, and this part is China. So Yellow Sea is between China and Korea. Remember that. East China Sea. Next you mention about East China Sea. East China Sea and South China Sea. So one lies at the south of China, one lies at the east of China. East China Sea and South China Sea. Fine. Next is Philippine Sea. Philippine Sea. Philippine Sea. Next you write down Celeb Sea. CELEB. Celeb Sea. Celeb Sea. CELEB. Celeb Sea. Next, another important sea you write down Java Sea. Java Sea. Java Sea. Next, you can mention this Arafura Sea. Arafura Sea. ARAFURA. Arafura Sea. And below that, Gulf of Carpentria. Arafura Sea, Gulf of Carpentria. Gulf of Carpentria. Next, Coral Sea. Remember last class we discussed Great Barrier Reef and etc. So write down Coral Sea. Coral Sea. And the last sea you write down Tasman Sea. Last sea is Tasman Sea. So you can see question might come like this. Okay, the Tasman Sea separates whom? So this is Australia. This is which one? New Zealand. Yellow Sea separates whom? Yellow Sea separates, like we discussed, Korea and China. Yellow Sea we have written Korea and China. Gulf of Carpentria separates two parts of Australia. Clear? Arafura Sea separates, okay, this with nothing but okay, island. This is Papua New Guinea Island. Papua New Guinea Island and Australia are something that are separated. Now Philippine Sea, you know that around Philippines. South China Sea separating nothing but okay, what? China with nothing but okay, Philippines. Japan Sea, you know that separating Russia with whom? Russia with nothing but okay, Japan. That is okay there. So those are the seas that lies in which ocean? These are the seas that lies in a Pacific Ocean. Marginal sea in the Pacific Ocean. Next you write on marginal sea in Indian Ocean. Marginal sea in the Indian Ocean. Okay, first you write down regarding Red Sea and Gulf of Aden. Red Sea and Gulf of Aden. Gulf of Aden. Next mention Persian Gulf and Gulf of Oman. Persian Gulf and Gulf of Oman. Persian Gulf and Gulf of Oman. Fine. Mention Arabian Sea, Lakshadweep Sea, Bay of Bengal. Arabian Sea, Lakshadweep Sea, Bay of Bengal. Bay of Bengal. Next you can mention Andaman Sea. Andaman Sea. Next you can mention Mozambique Channel. Mozambique Channel. Mozambique Channel. And lastly you mention Great Australian Bight. Great Australian Bight. Great Australian Bight. So these are the marginal sea that you are finding in which ocean? In the case of Indian Ocean region. Fine. The last thing that you write is what? The marginal sea in Arctic Ocean. Marginal sea in Arctic Ocean. Marginal sea in Arctic Ocean. Fine. First you can mention Chukki Sea. Chukki Sea. Chukki, Chukki Sea. Fine. East Siberian Sea, Laptev Sea, Kara Sea. East Siberian Sea, Laptev Sea, Kara Sea. East Siberian Sea, Laptev Sea, Kara Sea. Kara Sea. Fine. Then you have these two seas, Barents Sea. Barents Sea and Greenland Sea. Barents Sea and Greenland Sea. Barents Sea and Greenland Sea. Fine. Lastly, write down this Beaufort Sea. Beaufort Sea. Beaufort Sea. Fine. So these are the important, important marginal sea that you have to keep in mind. Question might come, which of the sea locates in what? Which oceans? Okay, that type of questions can be from the prelims. Clear? Now, some of the seas are this marginal sea is continuously in use. Okay, so UPSC asks other map-based questions from that, like which country is surrounding this sea or which country is surrounding that sea. That type of questions also being asked in the case of examination. So you write down important marginal sea. Heading you write down important marginal sea and countries surrounding those sea. Important marginal sea and countries surrounding those sea. Countries surrounding those sea. First we write down regarding Arabian Sea. So the first is Arabian Sea. Arabian Sea. Write down. Surrounded by India, Pakistan, Oman, O-M-A-N, Oman, Yemen, Iran, UAE, Maldives and Somalia. So here you lies your India. After India, what lies over here? Pakistan, then Iran, then here lies your UAE. This region is Oman, this region is Yemen, this region is Somalia. Fine. So this is okay, and here lies your Maldives. Okay, so this is okay, the country that is surrounding Arabian Sea. Next you write on Bay of Bengal. Bay of Bengal. Surrounded by India, Bangladesh, Bay of Bengal, India, Bangladesh, Myanmar, Sri Lanka, Thailand, Malaysia, Indonesia. Fine. Third, you write down Caspian Sea. Caspian Sea. Fine. Right on. Surrounded by Russia, Kazakhstan, Turkmenistan, Iran and Azerbaijan. Azerbaijan, Azerbaijan. Azerbaijan. Okay. Iran, Azerbaijan, Turkmenistan. 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 Next you write on Black Sea. Surrounded by Turkey. Bulgaria. 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 Romania. Ukraine. Russia. And Georgia. 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 Fine. Next we write on Mediterranean Sea. Right. Surrounded by Spain, France, Italy, Greece, Turkey, Cyprus, 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 Syria, Syria, Lebanon, Lebanon, Israel, Egypt, Libya, Libya, Algeria, Algeria, Tunisia, Tunisia. Next, Morocco, 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 Malta, MALTA, Malta. Morocco, Malta. Fine. So these are the countries that are surrounding the Mediterranean Sea region. Clear? Next you write on Baltic Sea. BALTIC. Baltic Sea. Write down Sweden, Finland, Russia, Estonia, Estonia, Latvia, Latvia, Lithuania, Lithuania. Next, Poland, POLAND, Poland. Germany, GERMANY, Germany. Denmark, DENMARK, Denmark. Fine. So these are okay. What? These are nothing but okay. Important point. Okay, we are finding Sweden, Finland, Russia, Estonia, Latvia, Lithuania, Denmark. These are the countries surrounding what? Surrounding your Baltic Sea. Fine. Next, you write down North Sea. Surrounded by Norway, Denmark, Germany, Netherlands, Belgium, France and UK. Next is Caribbean Sea. Surrounded by Cuba, Jamaica, Jamaica, Jamaica. Haiti, 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 Cuba, Jamaica, Haiti, Dominican Republic, comma, Venezuela, 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 Colombia, comma, Panama, 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 Costa Rica, Costa Rica, and Mexico. Next, we write down Red Sea, surrounded by Egypt, Sudan, Eritrea, Eritrea, Djibouti, 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 comma Saudi Arabia, comma Yemen, Yemen, etc. Last we read on South China Sea. Surrounded by China, Vietnam, Philippines, comma Brunei, Brunei, comma Indonesia, 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 comma Singapore, comma Taiwan, etc. Fine. So these are okay. These are the important part that you have to keep in mind with regard to, because these countries are always in use. When these countries are always in use, you're gonna get questions on these things. Fine. Can you answer 54? 54. Which is not there? Jordan. Yes, Jordan is not going to be there. Then Lebanon and Syria, they are touching. Yes. Okay. So answer here will be what? 3 and 4. Answer here will be what? 3 and 4. This is how the question has been asked. Like Mediterranean Sea has been asked, North Sea has been asked. Okay. There is a question in 2014 which asked Turkey located in which two sea. Turkey is locating between which two sea. Clear? So if you look at the map where the Turkey is being located, if you see the map where the Turkey is being located, it is located between Black Sea and Mediterranean Sea. Fine. So those type of questions has been asked. Okay, so if you remember the countries touching Black Sea, countries touching the Mediterranean Sea, you can remember that Turkey is the one which is touching both the sea. Okay, so this is your Black Sea, this is nothing but okay, what? Mediterranean Sea. Which country lies in between that? Turkey. Okay, so question was asked, Turkey, which country lies between Black Sea and Mediterranean Sea? So it is going to be what? It is going to be nothing but okay, Turkey. That is okay there. So if you remember which country are touching which particular region, you can easily mark okay the thing as a Turkey. Fine. How to remember these countries? Because okay, a lot of seas are there and a lot of names of the countries are there. So try to form your own mnemonics. Okay, try to form your own mnemonics, which through which you can remember. For example, some of the mnemonics, okay, which generally being used is what? Is a Tariq. Okay, this is a term which we use for remembering the Caspian Sea. Okay, so you see Turkmenistan, Azerbaijan, Russia, Iran, and Kazakhstan. Those countries are something that is okay referred like Garbat. Okay, this is generally being used for what? This is generally being used for nothing but okay, remembering the countries surrounding countries surrounding the Black Sea. Okay, for example, Georgia, Ukraine, Russia, Romania, Bulgaria. Okay, those countries are something that are okay surrounding surrounding okay the Black Sea. So try to form some short form. You try to find it out. Try to form some mnemonics which you can easily remember. So if countries okay, if question comes okay, which countries are surrounding, you just okay remember that it was Tariq. Okay, so which was the country? You can eliminate the options. Okay, so like this you can form some mnemonics whichever suits you better. You can form your own mnemonics and try to remember that these countries are surrounding Mediterranean Sea, these countries are surrounding the Black Sea, and etc. That is okay there. Fine. Any doubt regarding this particular part? Have a break and then we'll further continue. So next we are going to take up is an important strait of the world, and the important strait of the world we are going to take up, and it is okay what? So now we are going to take up important strait of the world, and what are the important strait that you are finding that we are going to take up, because that can come in the matching pair. That can come in the matching pair. Fine. So the first important strait that you write is what? That is right. That you write is a Park Strait. The first important strait is Park Strait. Okay, right on. The Park Strait separates India with Sri Lanka. Park Strait separate India with Sri Lanka. India with Sri Lanka, and connect the Bay of Bengal with Indian Ocean region, and connect Bay of Bengal with Indian Ocean region. Next we write on. So between this Sumatra, you can see this is Sumatra Island, this is Malaysia Island. In between that, this region, so in between that, this region you are finding is a water body. It is called as the Strait of Malacca. This is called as a Strait of Malacca. Very important trade route. Very important trade route for India. India generally trade with the eastern countries through this route only. Strait of Malacca. Strait of Malacca. Malacca. Write down. Separate Andaman Sea. Indian Ocean. Indian Ocean. Okay. So separates. You write a Strait of Malacca separates Malaysia with Indonesia. Malaysia with Indonesia. Malaysia with Indonesia, and connect Andaman Sea with South China Sea. Connect Andaman Sea with South China Sea. Andaman Sea with South China Sea. Next, this strait that you are finding, is called as the Java Strait or Java Strait. This strait is referred as a Java Strait. In bracket, you can also mention Sunda Strait, Sunda, Sunda Strait. This is also referred as a Sunda Strait. Sunda Strait. Right on. Connect Java Sea with Indian Ocean. Java Sea with Indian Ocean, and separates Java Island with Sumatra Island of Indonesia. Java Island with Sumatra Island of Indonesia. Indonesia. Important strait of the world. Next important strait that you are finding over here is a Yucatan Strait. So strait over here that you are finding is Strait So here you'll find a strait called as a Yucatan Strait. Yucatan Strait. Right on. Connect Gulf of Mexico. Connect Gulf of Mexico with Caribbean Sea. With Caribbean Sea, and separates Cuba with Mexico. And separate Cuba with Mexico. Cuba with Mexico. Next important strait you write down. Strait of Gibraltar. Strait of Gibraltar. Gibraltar. Strait of Gibraltar. Right. Separate Spain with Morocco. Separate Spain with Morocco. Spain with Morocco and connect Mediterranean Sea with Atlantic Ocean. Fine. Connect Mediterranean Sea with Atlantic Ocean. Fine. Next important strait that you find over here, it is referred as a Strait of Bab al-Mandeb. Mandeb. Strait of Bab al-Mandeb. Strait of Bab al-Mandeb. Bab al-Mandeb. Mandeb. Mandeb. Clear? Connect Red Sea with Gulf of Aden. Connect Red Sea with Gulf of Aden. Gulf of Aden, and separate Yemen and the Djibouti. Separate Yemen and the Djibouti. Separate Yemen and the Djibouti. Fine. Next, you write down Cook Strait. C-double-O-K. Cook Strait. C-double-O-K. Cook Strait separates North and South New Zealand. Separate North and South New Zealand. North and South New Zealand. Clear? Next, you write down Mozambique Channel. Mozambique Channel or Mozambique Strait. You can mention Mozambique Strait. Channel we have already read. You can mention Mozambique Strait. Where is Mozambique Strait? Okay. Right. Separate Mozambique with Madagascar. So this strait, this important strait, separate Mozambique with Madagascar. Mozambique with Madagascar. M-O-Z-A, this Mozambique. M-O-Z-A-M-B-I-Q-U-E, Mozambique, and Madagascar. M-A-D-A-G-A-S-C-A-R, Madagascar. Madagascar. Fine. Next important channel you write down, North Channel. North Channel. North Channel. Separate Ireland with England. Separate Ireland with England. Ireland with England. Clear? So this part is called as what? This part is called as a North Channel. Separate Ireland with whom? With the England. Okay, so we discussed when Ireland is also included, it is called as the United Kingdom. Otherwise, it is referred as a England and Wales. Fine. Next important strait you write down. The Strait of Taurus. T-A-U-R-U-S. Strait of Taurus. Fine. Strait of Taurus, where are you going to find? Fine. Write down. It separates Australia with Papua New Guinea. Separate Australia with Papua New Guinea. Strait of Taurus. Separate Australia with Papua New Guinea. Fine. Next important strait is Bering Strait. B-E-R-I-N-G. Bering Strait. So you can see this region, this is a Bering Strait. Bering Sea, you can see. This strait is called as a Bering Strait. Separate Russia with Alaska region. Separate Russia with Alaska region. Russia with Alaska region. Fine. Next important you write down Bosphorus Strait. B-O-S-P-H-O-R-O-U-S. Bosphorus Strait. I'll just show. So you can see this is a Black Sea, and this small sea is called as a Sea of Marmara. This small sea is called as a Sea of Marmara. So Black Sea is connected with Sea of Marmara, which is connected with the Aegean Sea, which is connected with what? Mediterranean Sea. So this is how the connection is there. So this narrow channel which is connecting is called as a Bosphorus Strait. It is referred as which strait? Bosphorus Strait. Right on. Connects Black Sea with Sea of Marmara. Connects Black Sea with Sea of Marmara and separate Turkey. Clear? So Turkey is called as a cross-continental country. This part of Turkey lies in Asia. This part of Turkey lies where? In Europe. Okay, so like Russia is a cross-continental, lies in also Asia, lies in Europe. Like that, okay, you see Turkey is Asia as well as nothing but, okay, Europe. This is, okay, Bosphorus Strait. Clear? Now this strait, this narrow channel which is connecting these two is called as a Dardanelles. Next you mention Dardanelles Strait. D-A-R-D-N-E-L-L-E. Dardanelles Strait. Right on. Connects Sea of Marmara. Connects Sea of Marmara with Aegean Sea. A-E-G-E-A-N. Aegean Sea. Aegean Sea. Aegean Sea. Okay. Separates Turkey region. Separate Turkey region. Okay. Next important strait you write down Strait of Hormuz. So this region, this as we discussed, this is called as which Gulf? Persian Gulf. This is a Persian Gulf and this is a Gulf of Oman. So this is connected with a narrow channel which is referred as a Strait of Hormuz. Strait of Hormuz. Clear? Very important for oil trade. Clear? All your oil trade happens through this only. So when Israel-Iran war was happening, you see recently what had happened. Iran was, okay, having a war with the Israel. So Iran tried to block this so that, okay, what will happen? So that no oil trade happens, and as a result, what will happen? The US will be forced to whom? US will be forced to, okay, ask Israel not to attack whom? Not to attack nothing but, okay, Iranian region. So this is, okay, important for oil trade. Clear? All these countries are Gulf countries are very rich in what? Oil. Okay, they are very rich in oil. So all the export happens through this region only. Clear? Strait of Hormuz. Right on. Connects Persian Gulf with Gulf of Oman. Gulf of Oman and separates Oman with Iran. And separate Oman with Iran. Separate Oman with Iran. Fine. So these are the important strait that you have to keep in mind. Okay, these are the important strait which is frequently in news. Okay, so we have taken up all these strait which are in news. So these strait, these marginal sea, and countries surrounding these marginal sea, you keep in mind. Fine. So next we are moving to the concept of oceanic water movement. Oceanic water movement. Fine. So there are three ways in which oceanic water moves. There are three ways in which oceanic water moves. The first is referred as a waves. Second is referred as a current. And the third is referred as what? Tides. Fine. So there are three different movement of oceanic water. The first movement is referred as a wave. The second movement is referred as a current. And the third movement is referred as nothing but tides. Fine. Now, why waves are being generated? Why waves are being generated? So this is a water. This is a water. And this is what? This is your air. So when air is moving, what will happen? When air is moving, water is not moving, water is static, air is moving, what will happen? A friction is going to be generated. So this friction will cause what? This friction will cause the disturbance in medium, leading to generation of water waves. Okay, so waves, oceanic wave, why they are generated? They are generated due to friction between whom? Friction between wind and water. Wind and water. As wind are moving, and water is trying to oppose, because water is static in nature. So because of this friction, what will happen? Medium is disturbed, and because of which, the waves are something that are being generated. Okay, so oceanic waves are generated due to what? Oceanic waves are generated due to friction between wind and water. It is generated due to friction between wind and water. Clear? These wave dies off quickly. These wave dies off quickly. Dies off quickly when it reaches shore. When it reaches shore or the oceans. So these wave dies off quickly when it reaches shore or the oceans. This you have to keep in mind. Fine. Why they dies off? Because water becomes what? Water has become shallow in nature. As you are moving towards land, what will happen to the water? Water becomes more and more shallower in nature. As a result, wave dies off. Fine. Fine. Clear? So the oceanic as forms, one is waves, second is what? Current, and third is what? Tides. Wave is generated due to what? Friction between wind and water. Wave dies off quickly when it reaches to the shore or ocean, and it is which type in nature? It is something that is shallow in nature. That is there. Clear? And as the things become more and more shallow, wave dies off. Wave dies off. Clear? The second important movement of the water is what? Oceanic current. So second important movement of water is what? Oceanic current. This is the second important movement of the water. Fine. Why current are something that are generated? Why current are something that are generated? It is generated because of two reasons. One we call it as a primary reasons, and the second is called as a secondary region. Both influences what? Both influences the generation of oceanic current. So primary also and secondary also. Primary forces, we call it as a oceanic current, are generated due to primary and secondary forces. The primary forces basically initiate movement of water. Initiate movement of water. So primary forces are something that are initiating what? Initiating nothing but movement of water, while secondary forces are influencing the flow of current. In which direction it is going to move? Influencing the flow of current. Fine. So primary forces are something that are initiating what? Initiating the movement of water from one part to another part, and the secondary forces are influencing the flow of current, in which direction it will move, at what speed it is going to move. Okay, that is influenced by whom? That is influenced by secondary forces. That is okay there. Clear? So what are the primary forces that are initiating what? Initiating the water movement? As we discussed, one is going to be what? Friction between wind and water. That is okay, one source which initiate the water movement. The second major force is what? The second major force is a Coriolis force. The third major force is a change in water level gradient. Change in water level gradient. Change in water level gradient. So all these three primary forces is responsible for initiation of whom? Initiation of oceanic current. Fine. Fine. So why wind is being generated? Why wind is being generated? Yeah, because suns is heating different what? Suns is heating the two region differently. So the region which is more heated, what will happen? Low pressure expansion will happen. Well, the region which is okay not heated is what? Compression, that is high pressure is going to be created. Okay, so one reason that you are finding is what? One reason that you are finding is a solar heating. Sun's heat things differently. That is why you see nothing but okay, what you see? Wind are being generated. Wind are being generated, and this wind movement is causing what? Causing the friction between wind and water, which is initiating the water movement. Fine. Any doubt regarding this one? The second thing that you have to keep in mind is what? The change in water level gradient. Change in water level gradient means what? Let's say this region have a less amount of water, this region have a more amount of water. What will happen then? What will happen then? Then you will see water will move from what? Higher gradient towards something but okay, lower gradient. Fine. So you have okay, you have two okay, what? Two water bodies. At one side you have okay, what? More water, and one side you have less water. So what will happen? Water will move from nothing but okay, higher side towards nothing but okay, lower side. Why this is happening? This is happening due to gravity. Water will move under the influence of gravity from nothing but okay, higher side towards nothing but okay, lower side. So even gravity is another factor which is influencing what? Influencing the circulation of water movement or influencing the current movement. Clear? So first reason is what? First reason is heating by the sun. Second reason is what? Second reason is nothing but okay, the gravity movement. Okay, that is okay there. Clear? Any doubt regarding this particular thing? So remember that why this primary okay forces are being generated. Why this primary forces are being generated? Primarily because of nothing but okay, what? The solar heating. Second is gravity, and the third you remember we discussed what is there? Rotation of earth. Since earth is not static, earth is constantly rotating on what? Earth is constantly rotating on its axis. Okay, so because of rotation, which force is generated? Coriolis force. Okay, because of rotation of earth, which is generated? Coriolis force. Fine. So what is happening is as okay, what? As nothing but okay, the earth is okay rotating. If okay, we discussed if water is moving from here to here, because here higher gradient, here what is happening? Lower gradient. But okay, by the time water will start moving because of earth rotation, this will shift from where to where? This part will shift from here to here, because earth is rotating. Earth is not static. Earth is constantly okay rotating like this. Okay, so when the water starts to move from this region to this region, what is happening? Okay, what is happening? It has to move in a okay straight line. It is have to move like this. But by the time okay, what will happen? Water is coming to this direction. This region is okay, what? This region is moving other side because of rotation of earth. So water will be deflected. Water also will be nothing but okay, deflected. That is okay there. Their movement will not be straight. Their movement will be what? In a deflected manner. Why this is happening? This is happening due to which force? Coriolis force. Okay, so we say deflection is happening due to which force? Deflection is happening due to Coriolis force. Okay, so this is happening due to Coriolis force. Fine. So remember that okay, the primary forces is the one initiating the flow of water. Why this primary? What are the primary forces? Frictional forces, Coriolis force and change in water level gradient. And why this primary forces are generated? Because of solar heating, because of gravity, and because of what? Rotation of earth. That is okay there. Clear? On the other side, secondary forces influences the flow of current. What are the secondary forces? Basically your temperature and salinity. Temperature and salinity. So secondary forces are the one which is influencing the flow is temperature and salinity. Fine. Remember we discussed if the water is more denser, then what will happen? It will go down. Yes. Okay. Water is more denser, go down. So saline water is what? Saline water we discuss is a more denser. So more denser water will go down and less denser water will what? Come up. Okay. That is okay there. Clear? So it will cause the movement. It will cause the movement of nothing but okay water. Similarly, we discuss if the water is okay hot. If the water is hot, temperature is hot, then what will happen? As we discussed, what is density? Mass by volume. If anything is hot, then what will happen? Volume will increase. Volume will increase. What will happen to density? Decrease. Okay. So what you see is warm water is going to what? Warm water is going to come up because it has a less density, and cold water will what? Come down because cold water will be what? Cold water will be having lesser volume. Lesser volume is higher density. So cold water will come down. Clear? So temperature and salinity is influencing also the movement of influencing also the movement of water. So that's why they are referred as which type of forces? They are referred as a secondary forces responsible for what? Responsible for nothing but okay movement of water. Fine. Any doubt regarding this particular thing? So why the oceanic currents are being generated? Oceanic currents are being generated because of what? Because of either primary forces or secondary forces. That is okay there. Primary forces influences is generated due to what? Generated due to solar heating, gravity, as well as nothing but okay rotation of earth. Secondary forces, why it is generating? Because of temperature variation and salinity variations. Fine. Any doubt regarding this one? So these are okay what? These are the things is responsible for what? Responsible for generation of oceanic current. Any doubt regarding this one? So oceanic wave, as we discussed, oceanic wave are simple movement. What is why this simple movement? Because when wind is blowing, water is trying to oppose this particular movement, and as a result what will happen? Waves are being generated. So this is okay what we called as what? This is what called as a oceanic wave. But oceanic wave are okay not very long movement, short movement of water. They dies off quickly as it reaches to shores and etc. That is okay there. Clear? But current are a large movement of water. Okay, they are large movement of water from one region to another region. Clear? So what oceanic current does? What oceanic current does, because we discussed it is a large movement of water from one location to another location. Large movement of water initiated due to primary and secondary forces large movement of water initiated due to primary and secondary forces taking water from one location to another. So what oceanic current does? Oceanic current determines what? Determines the precipitation or rainfall. Clear? Where rainfall will happen, where rainfall will not happen is going to be determined by whom? Determined by nothing but okay the oceanic current. So we discussed wherever cold oceanic current are there, yeah, less rainfall and deserts are being formed. Less rainfall, deserts are being formed. And wherever warm oceanic currents are there, more rainfall are there. Warm oceanic current are there, more rainfall are there. So one thing that oceanic current determines is what? Which region will have more rainfall and which region will have lesser rainfall. Second thing, it also determines formation of cyclones. Formation of tropical cyclones. Remember, tropical cyclones are formed where? Tropical cyclones are formed where? We discussed they are always formed on the eastern side. Why they are formed on the eastern side? Because we discussed warm oceanic current are going. Clear? For tropical cyclone, remember we discussed what is the condition required? that ocean need to be what? Ocean surface need to be heated. Warm oceanic surface are required. That only will happen when, okay, warm oceanic current will flow. So formation of tropical cyclone also decided by whom? Also decided by oceanic current. Oceanic current also determines navigation, trade. As we discussed, movement becomes easier. Wherever water is moving, it is easier to move with the water. You are trying to move, okay? If water is moving this side, you are trying to move away, then what will happen? Difficult to move. So it also determines your navigation as well as nothing but, okay, trade. Fine. It exchanges what? It exchanges the heat from equatorial to polar region, equatorial to polar region, thus influencing the climate. Thus influencing the climate. Exchanges. So extra heat from equator region is moving to the polar region, and extra cold from polar region is coming towards equatorial region. That's why it is, okay, influencing climate. Fine. If you remember, when we discussed British type of climate, we discussed though temperature is cold, port of the British is never frozen. Why port of the British is never frozen? Because of the warm oceanic current reaching to what? Reaching to the Britain. Clear? So we have discussed this. So you are finding this. You see, warm oceanic current is reaching to what? Warm oceanic current is reaching to the coast of Britain. Here, which current is reaching? Warm oceanic current are reaching, and as a result, what will happen? Port here are never frozen. In Britain, port are never frozen because warm water is something that is reaching to this particular shore. So it also influences what? It also influences nothing but, okay, the climate of this particular region. So where do you see British type of climate? Where you will not see British type of climate? You are seeing because of, okay, oceanic current only. Fine. Another important things with regard to oceanic current are what? Remember, we discussed wherever warm oceanic current meet cold oceanic current, what will happen? Yeah, it is very good for fishing. Wherever warm oceanic current meet the cold oceanic current, we discussed this is very important fishing zone. This is very important fishing zone. Why? Because we discuss if warm oceanic current is meeting with the cold oceanic current, this is a cold water, this is warm water, we discuss what will happen. Cold water more denser, so starts to go down, warmer water will starts to come up. This will lead to what? This will lead to nutrients from the bottom of the ocean coming towards top, and as a result more fishes are being found in this particular region. So this also influences, okay, which is your fishing zone, which is your not fishing zone. That is also determined by who? That is also determined by the oceanic current. Clear? So these are, okay, what? These are the important part that you have to keep in mind, why it is important to study the oceanic current. Clear? So remember why oceanic currents are being generated. Oceanic currents are being generated due to primary or secondary forces. What are the secondary forces? Temperature, salinity, which can cause nothing but, okay, the movement. And, okay, what you see is, okay, why primary forces are generated due to solar heating, gravity, as well as rotation of earth, causing these particular things to occur. Fine. Any doubt regarding this one? Now we are coming to the types of oceanic current. Fine. So based on temperature, the oceanic current can be divided into two types: warm oceanic current and cold oceanic current. These are the examples of warm oceanic current: Gulf Stream, Agalhas current, East Australian current, Brazilian current, Kuroshio current. These are example of warm oceanic current. Canary current, California current, Venezuela current, West Australian current, Peru current, Labrador current, Oahu current. Okay, those are examples of what? Those are examples of cold oceanic current. Fine. Fine. And as we discussed, if movement of water is like this, if movement of water is like this from here to here, then it is going to be called as which type of current? Surface current. If the movement of water is like this, then it is going to be called as which type of current? Deep current. Okay, so if water moving down, then it is going to be called as a deep current. If water moving onto the surface, then it is going to be called as what? Surface current. Fine. If the water is moving onto the surface from here to here, water is moving, then it is going to be called as which current? Surface current. If water moving down, moving up like this, then it is going to be called as which type of current? Deep water current. If water moving down and moving up, it is a deep water current. If it is flowing onto the surface, then surface current. Fine. Fine. Any doubt regarding this one? So this is okay. Important thing that you have to keep in mind with regard to oceanic current. Fine. Now come to this figure. So come now we are saying that Earth is rotating on its axis. Clear? How Earth is rotating? They are moving from west towards what? East direction. Okay. So when they are moving from west towards east direction, what will happen? If any body moves in a circular motion, what will happen? We discussed two forces are acting. One is centripetal force, which is trying to attract towards center, and another is what? Centrifugal force, which is trying to act outward. Clear? So when it is moving like this, water will what? Water will start from here to here. Clear? Because the Earth is rotating like this. When Earth will rotate in a circular manner, what will happen? A force will act towards nothing but okay what? Towards nothing but okay center side, and this is okay leading to what? This is leading to the formation of which current? Which is leading to formation of which current? Equatorial counter current. You can see this counter current are there. Clear? When things will move from here, then what will happen? What will happen? Water will move from where to where? Water will start moving from west towards eastern direction. Why water will start moving from west towards eastern direction? Because Earth is rotating from where to where? West towards east. Okay, so Earth is rotating from west to east. Water will start moving from here to here. Clear? So when water start moving from here to here, what will happen? Let's say this is okay. What? This is okay. This is the water. When water start moving from here to here, what will happen? Here you will see more amount of water will get deposited. All the water will come towards which side? Eastern side. Okay, that is okay there. So it is moving from west to it towards east. When Earth is moving like this, water also will move okay towards nothing but okay which direction? Eastern direction. So more water will be accumulated where? In the eastern direction. Less water will be accumulated where? In the western direction. That is okay there. Clear? So now you see a change in gradient. Okay, one side you see nothing but okay what? More accumulation of water. One side you see nothing but okay less accumulation of water. So we discuss what will now happen. Okay, we discussed because of change in water gradient, because of the gravity, water will start moving from where to where? high to nothing but okay, low. Okay, so water will start moving from where to where? From high to low. Just now we discussed primary forces. Primary forces, we have written change in water level gradient. Why this change in water level gradient is happening? Because more water is moving towards eastern areas. So eastern areas, you will see what? High water, and western areas you are going to see nothing but okay, lesser amount of water. So as a result, water will move from where to where? From nothing but okay, high region to nothing but okay, lower region, that is okay there. So that's why you see there are two current that are being generated. Okay, there are two current that are being generated. One is okay, what? One is this current, that is water moving towards okay this side, equatorial counter current. Water is moving towards which side? Eastern side. And when more water will pile up towards eastern side, what will happen? A counter current okay will move like this, which is called as a north equatorial current and south equatorial current. Okay, so if it is blowing in northern hemisphere, north equatorial. If it is blowing in southern hemisphere, what will happen? South equatorial current. Okay, so north equatorial current and south equatorial current. Fine. Any doubt regarding this particular part? So what you have to keep in mind is what? What you have to keep in mind is equatorial current. Equatorial current, why it is generated? Equatorial current, why it is generated? This is generated because earth is rotating from where to where? From west towards east direction. As a result, more water will move from east. Okay, more water will be accumulated towards eastern direction. When more water accumulated, a counter force will nothing but okay move from here to here. So what is happening is, I'll just make this diagram. This is a level of water. This is a level of water. Now what is happening is, because of earth's rotation, what is happening? Water start moving from here to here. Water start moving from here to here. So as a result, what you will see? You will see accumulation of water over here and decline in the water over here. Now what will happen? Because of this, a counter current will now move from where to where? From here to here. So that's why two current are being developed. Okay, one is called as what? One is called as a equatorial counter current, another is called as a north equatorial current. And same phenomena, if it is happening in southern hemisphere, it is called as what? South equatorial. So you have south equatorial, north equatorial, south equatorial, north equatorial, south equatorial, north equatorial, south equatorial, north equatorial. In all the ocean, you will see water starts moving from here to here. Here more water, so as a result, this okay current will start moving like this. Fine. Any doubt? Now whenever current will move from where? From equatorial region. When current will move from equatorial region towards polar region, it is going to be which current? Warmer current, because equator receive more sunlight. So when okay this moves from where to here, from equator towards polar, which type of okay current it is going to be there? Warmer current. When it is moving from polar towards equator, then it is going to be which type of current? Colder current. So all blue signs okay is a colder one, all red signs are which one? Warmer one. Okay, that is okay there. Clear? So you are finding what? You are finding this high. This is how you are moving south equatorial. Now when south equatorial is coming towards Brazilian part, what will happen? Because okay, now this is a coast. Now this coast will divert water towards where? Divert water towards nothing but okay downward side. So as a result, this will change into which type of current? Brazilian current. Now this will come down. Now Antarctic coast will now change water. Okay, Antarctic coast will cause the water to nothing but okay move towards this side. Now this again will move okay, start moving up because of nothing but okay what? Because of nothing but okay water encountering nothing but okay again a coastal region. So this is okay called as which current? This is called as nothing but okay Venezuela current. So when it is moving from polar to nothing but okay equatorial region, as we discussed, colder current, from here to here it is going to be nothing but okay warmer current. Clear? So you just make this diagram, rough diagram like this. Okay, rough diagram, just you make like this. Here you make Northern America, Southern America, you make Africa and Europe like this, and you write heading current in Atlantic Ocean. Current in Atlantic Ocean, just make rough diagram like this. Show first which current? Equatorial counter current, then North Equatorial Gulf Stream, Canary current. Okay, this you show, and at the downward you show Brazilian current, South Atlantic current, and Venezuela current. Okay, so that current you show at the southern side. Fine.
Sorry, just now you said the Atlantic current. It will touch the coast.
Water is moving like this, no? But because of, okay, what? Brazilian coast, what will happen now? Water will be diverted like this.
Yes, sir, but when it will go to Peninsula,
Hmm.
why will it turn that way?
Because, okay, water is moving like this, okay, it is encountering this coast, okay, so it is encountering the coast, as a result, it is moving up. Some water will move this side, some water will move up, okay, so that is why you see South Indian current and like this, okay, you are seeing whole water is moving, no? Entire water is moving from here to here. So some water will encounter the coast, they will start moving towards upper side, some will move towards this side, right? So just what you do is, so make like this. So here you show which current is coming. Labrador, you can use different pen. Labrador is which current? Colder current. Here which current is going? Gulf Stream. Gulf Stream is which type of current? Warmer current. Here you show which current is going? Atlantic drift, North Atlantic drift. So this current is going North Atlantic drift. This is going to be which type of current? Warmer current, because Gulf Stream is changing into North Atlantic drift. Then here you will find which current is coming. Which current is coming? Canary current. Canary current is which current? Colder current. Fine. Here we discussed just now which current will flow like this. Which current will flow like this? Equatorial counter current. And which current will flow like this? North equatorial current. The same we discussed also in the southern hemisphere, south equatorial current. Then it will turn into which current? Brazilian current. Then it will be South Atlantic current. And then it will change into Venezuela current. So this is okay, colder current. This is warmer current. This is warmer, colder. So this is okay, how you make a diagram regarding current in the northern Atlantic oceans and the southern Atlantic oceans. Fine.
The South Atlantic is cold current.
Which one? Yeah, this is mostly colder, this is mostly warmer. Equatorial are mostly warmer, this is mostly colder current. Fine. Now one more thing that you have to keep in mind, this entire circulation, this one complete circulation of current. So current like this, it is moving, you see south equatorial current, then changing into which current? Brazilian, then changing into South Atlantic current, then moving like this. This one complete circulation of current is called as what? Is called as a gyre. One complete circulation of current is referred as what? Gyre. Clear? Here also you see current is what? Moving like this, coming back like this, then moving like this. This one complete circulation of current is going to be called as what? Gyre. So this gyre is referred as what? This gyre is referred as a Columbus gyre. Well, this gyre is referred as nothing but Prince Henry gyre. Clear? So this South Atlantic gyre is referred as which type of gyre? Prince Henry gyre. The North Atlantic is referred as which type of gyre? Columbus gyre. It is named after Columbus because you know that Columbus founded who? The route to America. He founded the route to America. Voyages started. He founded the route to America. So he started voyages from here, and then he went towards nothing but America. So that's why Columbus gyre. And the Prince Henry was the one who finances a lot of voyages. Like Vasco da Gama came to India, like Columbus came to India. So he financed a lot of nothing but voyages at that point of time. So that's why it is referred as which type of gyre? Prince Henry gyre. So one complete circulation of oceanic current is going to be called as what? One complete circulation of oceanic current is going to be called as a gyre. The South Atlantic, it is going to be called as what? South Atlantic, it is going to be called as what? Prince Henry. North Atlantic, it is going to be called as what? the Columbus Gyre. Fine. Any doubt regarding this part? Now, current are moving in which direction? Current are moving in this direction. Which direction is this one? Clockwise. This direction is which one? Clockwise. This direction is which one? Anti-clockwise. So current are going to move in clockwise direction in which hemisphere? Northern hemisphere. And anti-clockwise in which hemisphere? Southern hemisphere. So oceanic current are going to move in which direction? Anti-clockwise in the northern hemisphere. Clockwise in northern hemisphere and anti-clockwise in which hemisphere? Southern hemisphere. Remember wind movement? Wind, how it moves? We discussed climatology. Wind, how it moves? Wind moves in anti-clockwise in northern hemisphere and clockwise in what? Southern hemisphere. Cyclones, remember, anti-clockwise in northern hemisphere. So opposite movement. Current is opposite to nothing but, okay, what? Water movement is opposite to air movement. Okay, so cyclone moves anti-clockwise in northern hemisphere and clockwise in southern hemisphere. The oceanic current, okay, water moves opposite to nothing but, okay, air. So oceanic current move clockwise in northern hemisphere and anti-clockwise in a southern hemisphere. Clear? So this is, okay, what you are finding with regard to the current that you are seeing in case of what? In case of Atlantic oceans. Fine. Now the other part we have discussed is what? Yes. Yeah, Venezuela is cold current. This is cold current. This is Brazilian is a warm current. Clear? In Pacific Ocean, what you are seeing? So again, we discuss what is happening. Since Earth is rotating, what will happen? Water will move from where to where? Water will move from here to here, west towards east, because Earth is rotating how? West towards east. Okay, that is okay there. When more water will be over here, then what will happen? When more water over here, what will happen? So we discussed, okay, this is okay, water level, water is moving from here to here. So more water is piling up over here. When more water will pile up over here, what will happen? Okay, because of gravity effect, water will start moving from here to here. So that's why you see movement of these two current, north equatorial and south equatorial current. Then this north equatorial current reaches where? Reaches the coast. It changes into which current? Kuroshio current. Then from here, polar region, which current is coming? Oyashi current is okay, something that is okay coming. Now this is reaching to what? This is reaching in the form of North. Kuroshio is reaching in the form of North Africa. Then coming back in which form? California current form. Again, this will divert the water towards nothing but, okay, this one. In the Southern Ocean, what is happening? You have East Australian current formation. Then what will happen? It will move into South Pacific, change into which current? Peru current. So Peru current is okay, colder current. While, okay, we discuss East Australian current is which type of current? Warmer current. Okay, that is okay there. Clear? So this is how you are seeing formation of current in the case of Southern, okay, formation of current in the case of South Pacific Oceans and North Pacific Ocean. So just quickly make diagram like this. So you can quickly make diagram like this. Okay, so show this as which part? Show this as Eurasia part. Show this as Australia part. This is where how equator is something that is okay passing up. And this is okay North America. This is nothing but okay your Southern America. So from here to here we discuss which current is going to come. From here to here which current is coming? We discuss equatorial counter current. Counter current. And when we discuss when more water will pile up over here, what will happen? An opposite current will move from here to here and move from here to here. It is going to be called as a north equatorial current and south equatorial current. Fine. When this north equatorial current is reaching over here, it is changing into which current? Kuroshio. It is changing into which current? Kuroshio. From here, what is coming? Oyashi. Oyashi is which type of current? Colder, because coming from polar region is colder. It is coming from equatorial region means warmer current. Then this will move towards this side, and which current is okay blowing over here? We discuss California current. This California current is going to be which one? Colder current. Then it will merge into this particular side. Here what current is going to be there? We discuss East Australian current. because it is being on the eastern side of Australia. So East Australian current, it is warmer current because current is moving from equator towards polar region. From here to here, which current are there? South Pacific current. South Pacific current, and this current is changing into which current? It is changing into which current? Peru current. So Peru current is which type of current? Colder current, because moving from polar region towards nothing but equatorial region. Fine. So to quickly make this diagram regarding the current in the southern and North Pacific Oceans. Fine. And we discussed one complete circulation is going to be called as what? Gyre. Okay, so which gyre is going to be this one? Which gyre is going to be this one? It is called as a turtle gyre. No, Columbus is in the Atlantic Ocean. This gyre is referred as which gyre? Turtle gyre. This gyre is referred as which gyre? Heyerdahl gyre. Heyerdahl gyre. Okay, so this entire complete circulation of oceanic current is called as a gyre, and this inside important current that you are finding is called as a Heyerdahl gyre. Fine. So this is turtle gyre. This is nothing but Heyerdahl gyre. One more thing which we missed in previous one, just add that over here. Now here, when Columbus gyre is being formed over here, one sea you're gonna find, a sea you're gonna find in this between, which is called as a Sargasso Sea. Sargasso Sea. You're gonna find a sea over here in between, because ridges are there. No, you know that Atlantic Ocean, what is being formed? Ridges are being formed. So in between ridges, you will find a sea which is called as a Sargasso Sea. Clear? It is only sea which is not touching what? Only sea which is not touching the land part. Okay, so like we discussed, all the sea, Arabian Sea, Bay of Bengal, all are touching the land part. The Sargasso Sea is not touching nothing but the land part. This is formed in the North Atlantic Oceans. Fine. So remember that Sargasso Sea. Okay, and then you make this diagram. Turtle gyre and Heyerdahl gyre. Remember, California's current is which type of current? Cold. Peru is which type of current? Cold. And which is moving from equator is going to be warmer current. Clear? So remember, we just now discussed wherever warm and cold current are meeting, good zone for what? Fishing. So that's why Japanese coast, we discussed where this is meeting is very famous for fishing and other aspects. Fine. The last section that you are seeing is what? The last section that you are seeing is the Indian Ocean region. So last section that you are seeing is the Indian Ocean region. Now in Indian Ocean, you are not seeing much current movement in what? Northern hemisphere. Northern Indian Ocean, you are not seeing much current movement. Why? It is not connected with the polar region. Landmass is there. Here they are connected with the polar region. This Atlantic Ocean is connected, Pacific Ocean is connected, but here landmass is there. It is not connected with nothing but what? Not connected with the the ocean polar region. So that's why you don't see much of the current movement in the northern hemisphere. In the southern hemisphere only you see nothing but much of the current movement. Clear? So as we discussed, Earth is rotating from where to where? From west to east. Water will start moving from where to where? Here. So more water will pile up over here. When more water will pile over here, what will happen? Due to gravity, a counter current will start. So this is going to be called as a north equatorial and south equatorial current. So when it reaches to this point, what will happen? The coast will divert water towards downward side. So which current you are finding over here? Agalhas current. Then South Indian Ocean current. Which current you are finding? West Australian current. So this current you are seeing in the case of what? This current you are seeing in the case of Southern Ocean. And we discuss one complete circulation is going to be called as what? Gyre. Which gyre is over here? It is referred as a Mazid gyre. It is referred as which gyre? Mazid gyre. Okay, it is referred as a which gyre? Mazid gyre. So quickly make diagram like this. Make Africa like this. Make Australia like this. Okay, and just make this diagram. Okay. So only Southern Ocean you have to make it. So mention here, which current is there. equatorial current. Which current over here? Which current over here? South equatorial. Then which current over here? Agar last current, warmer current, you write it. South Indian Ocean, West Australian current. Okay, just make this diagram. Done? Fine.
South Indian current will be cold.
Yeah, this will be colder. Can you answer now this question? Fifth one. South Atlantic and Southeastern Pacific region in tropical latitude, cyclone does not originate. What is the reason? So we discuss Southeastern Pacific means which region it is talking about. This is okay. What? This which current is blowing from here to here? We discuss South Equatorial. It changing into which current? West Australian current. Then changing into which current? Sorry, East Australian changing into which current? South Pacific. And then which current? Peru current or Humboldt current. This is okay. The movement that is happening in the southeastern. Now, which is southeastern direction? This is north, this is south, this is southeastern direction. Clear? So southeastern direction, which current is flowing? Peru current. Peru current is warmer current, colder current. Colder current. So we discuss whenever colder current are there, sea surface temperature is going low, and as a result, what will not originate? Tropical cyclone will not originate, because tropical cyclone, what is the condition requires for tropical cyclone to originate? Warm surface, warm sea surface, not cold sea surface. Okay, so just now we have written with regard to what? With regard to tropical cyclone, you require which type of surface? You require nothing but okay, warm sea surface, not the cold sea surface. Fine. Another question that you can see over here. Fourteenth, what is the answer?
So Earth's rotation.
Earth rotation on its axis. Any other thing? Clear? Now in this question, what you see is we discuss what explains the eastward flow of equatorial current. So when you see this figure, so we discuss, question is asking why there is okay, what? Why there is a this type of nothing but okay, eastward flow. Eastward flow, that is why there is a eastward flow. So what you see is, okay, north equatorial current and south equatorial current are converging where? They are converging where? They are converging on the west side, and as a result, what will happen? Water will move from where to where? More water accumulation. More water accumulation means water also will move from where to where? From west to east side. Okay, that is okay there. So two reasons. One is rotation, as we discussed, Earth is rotating, so water is moving from west towards east. And the second reason, okay, that you see is, okay, what? Both these current are converging over here. When both these current converge over here, more water accumulation over here, and as a result, okay, you'll see this movement towards this particular side also. You'll see movement towards this particular side also. Clear? So here the answer is going to be what? Answer is going to be, so here the answer is going to be convergence of two equatorial current. Okay, north equatorial current is also going, south equatorial current is also going. Both current are converging. When both current are converging, what will happen? You'll see counter current is going to flow. This is called as a eastward flow. So this is how the question has been asked in the case of nothing but, okay, examinations. Clear? Any doubt regarding this particular part? So Earth's rotation is on the axis, and also nothing but, okay, two movement of water is happening. North equatorial current is also going over here, south equatorial current. So when two current will converge, more water over here. More water means what? Here the water level will go up, here the water level will come down. As a result, what will happen? Movement, okay, will happen from high region to low region. Fine. So this is, okay, how the question has been asked in the examination regarding oceanic current part. Fine. Any doubt regarding this one? So what you have to keep in mind is, what is oceanic current? What is the difference between oceanic waves and current? What difference between oceanic waves and current? Yeah, wave generated due to the friction between wind and water, and wave is what? Shorter movement. Wave dies off quickly. What happens to the current? What happens to the current? It is a large movement of water from one location to another location. And why this movement of water occurs? Why this movement of water occurs? Due to two forces, primary forces and secondary forces. What are the primary forces? What are the primary forces? Yeah, the change, water level gradient change, the Coriolis force, and wind and friction between wind and water. Why friction between wind and water is generated? Solar heating. Why movement of water from higher to lower? Gravity. Clear? And why there is, okay, what? Why there is a Coriolis force generated? Due to rotation of Earth. That is okay there. Clear? So we discussed this is causing the primary forces. What is secondary forces? Temperature and salinity. Salinity causes what? Salinity causes water to be more denser. As a result, we discussed denser water will what? Go down, and warmer, okay, less dense water is going to come up. Similarly, we discussed, okay, with regard to what? With regard to the warmer temperature also, warmer water is going to be what? Less dense. So warmer water will come up, and colder water will nothing but, okay, come down. Clear? So remember, this large movement of oceanic current is happening due to what? Due to primary forces and secondary forces. Fine. Any doubt regarding this particular thing? So yes.
So because of rotation of Earth, firstly, the counter current from west towards east. And in the east, convergence will happen.
Yeah.
Because a lot of quantity of water is being
Yeah.
to the east.
Yeah.
And from there will be movement in the eastern hemisphere.
Eastern.
Western to eastern hemisphere. So it because of rotation, petroleum counter current is generated, but because of convergence of water and accumulation, the northeast and southeast current.
North equatorial and south equatorial current. Yeah, that is generated. Fine. So this is, okay, what you have to keep in mind with regard to the concept of current. Clear? Any doubt? Now you can go and solve 2019 paper. 2019 paper also there was a question on, okay, what? Equatorial. Just go and check, okay, 2019 paper also. The question was asked regarding forces. Which forces is responsible for generation of oceanic current? Fine. So this is how the question can come with regard to oceanic current. Fine. So what we try to cover today is what? What we try to cover today is concept of oceanic salinity. Where salinity will be more? Where salinity is going to be more? At the Tropic of Cancer and Tropic of Capricorn. In equatorial, what will happen to salinity? Lower salinity. In polar region, what will happen to salinity? Lower salinity because of addition of what? Fresh water. Which is the lake recording highest salinity? Lake Van of Turkey is recording the highest amount of salinity, which is the lake we have discussed. Lake Van of Turkey is recording highest amount of salinity. Dead Sea lies where? Israel Jordan border. It is the lowest point on the earth, and we discuss lowest point on the land, and we discuss it is okay also recording what? High salinity. Fine. Then we discuss differences between Isthmus, Strait, Bay, and Gulf. What is a Gulf? What is a Gulf? Yeah, three side land and narrow opening, then it is going to be called as a Gulf. And okay, what is okay? The Bay. So okay, like we discussed, this is called as a Gulf of Kutch. Why this is called as Gulf of Kutch? Three side land and narrow opening, and this we called as a bay. Three side land with a wide opening towards water. So Bay of Bengal and Gulf of Kutch name is being given. Then we discussed the term Strait and Isthmus. What is the difference between Strait and Isthmus? Yeah. Two not ocean, two water bodies you mentioned, because okay, it can connect okay the two water bodies, okay, and separates the land part. Fine. So this is okay, Strait as well as nothing but okay the Isthmus we have discussed. Remember the important strait where we discussed Strait of Hormuz. Where do you find Strait of Hormuz? Strait of Hormuz. Which two water bodies is connected with the Strait of Hormuz? Persian Gulf and Gulf of Oman. Okay, Persian Gulf and Gulf of Oman. We discussed most of the oil trade happens through which route? Strait of Hormuz. Okay, we discussed Strait of Gibraltar. Gibraltar separating which one? Africa and Morocco and okay the Spain. Africa and Europe are being separated. So what you see is okay, Strait of Gibraltar you keep in mind. So important strait what we have discussed, just keep that in mind. What is marginal sea? What is marginal sea? Partially enclosed water bodies, and all your these Gulf of Kutch, okay, Bay of Bengal, we discussed your Gulf of Mexico, all these are okay. What? All these are your marginal seas, that is okay there. So remember, marginal sea in Atlantic Ocean, marginal sea in what? Indian Ocean, and marginal sea in what? Marginal sea in the Pacific Ocean. Clear? So we are left with the third type of water movement. So we are done with the oceanic wave, we are done with the oceanic current. We are left with the third type of water, which is okay, what? Tide movement. So we'll take up tide movement in tomorrow's class and then finish the oceanography part. Anyone having any doubt? Thank you. Thank you.